Good afternoon everyone, and welcome to my first worked exam answer video in what feels like a very long time, for which I wholeheartedly apologise. And it's the first video using my new Olivia stand, whereby I'm going to be able to do all of my annotating and working out live for you as we're going along, which I'm quite excited about because I'm hoping that it's really going to help you guys to see what I'm doing with the information in the question, what all my working out is, and kind of how I would lay that out as I'm going through it, and then obviously what the answer to the specific question is. So this first question that I'm going to do in this video is from the 2023 AQA AS level paper, and the question that I've chosen, question 4, is an ideal gas calculation, but we're also having to use reacting mole ratios in here as well. We're also having to use moles mass and MR in here as well, and then we're going to have to identify what one of the components of our starting compound is. So I've got my two highlighters, and the reason why I've got two is because we're going to be given information about M, and we're also then given information about the mixture of gases. So we are told that M is a group 2 metal. So when it comes to identifying M, we want to be looking at group 2 on our periodic table, and we're told that it will form the nitrate with that particular formula there, which is going to be helpful when it comes to determining the MR and working out what M is. We're told the mass of MnO3 that is heated strongly, and then we're given an equation for that decomposition. So the M nitrate is our reactant, and we're decomposing that to make MO as a solid, 4 lots of NO2, which is a gas, and 1 mole of oxygen, which is also a gas. It then tells us that the mixture of gases, and that's mixture is a key word here because we're going to be thinking about all 5 moles of gas made in total, and that mixture of gases has a volume of 225 centimeters cubed at a temperature of 450 degrees and a pressure of 101,000 pascals. Our goal is to determine the MR of the M nitrate so that we can then identify M, and we're also given the gas constant, as we always would for a question of this ilk, as 8.31 joules per Kelvin per mole. So if you've watched some of these videos before, you'll be well aware of the fact that I'm very fond of using a highlighter or two to help me to see what information in the question is relating to what. Now, this isn't necessary, it's not something I am telling you you have to do. The benefits for me of doing this are that I now know that I'm kind of dealing with two separate parts of that equation, and that once I've dealt with everything in the pink about the gases, I can then think about everything in the orange. And I've done similar to this with things like a titration, where I do everything to do with the acid in one colour, everything to do with the alkali in another colour, or in a redox titration, everything to do with what is being reduced in one colour, everything to do with what's being oxidised in another colour. Like I say, not essential, but I think it helps. So, first thing I'm going to do is grab my calculator. The second thing I am going to do is I am going to convert my units for my PV equals nRT equation. So we need to make sure we know what the standard units are for volume, temperature and pressure. So pressure will need to be in pascals, and it already is, which is great. Sometimes it might give us that in kilopascals, and if it does, you'd be timesing it by 1,000 to get it into pascals. Temperature needs to be in Kelvin. So to convert 450 degrees Celsius into Kelvin, we're going to add 273. So 450 add 273 is 723 Kelvin. And then volume, we've been given it in centimetres cubed, and we actually want it in meters cubed for our ideal gas calculations. For every other type of calculation it will be decimeters cubed, but for this one, the ideal gas calculations, the standard unit would be meters cubed. So to get my 225 centimeters cubed into meters cubed, I need to divide by 1,000,000. It's going to give me a really lovely small number. Of 2.25 times 10 to the minus 4 meters cubed. Now, even if you weren't sure where to go with the rest of the question, you will probably pick up a mark for those two conversions. And if you are, again, not sure where to go with this question, if you can ever work out the moles of anything, that's a pretty handy starting point. So now that we've got our volume in the right units, our temperature in the right units, we've got pressure, we've got the gas constant, we can rearrange the PV as nRT equation to give us moles equals. So moles is going to be equal to, I'm going to need to take the RT underneath the PV on the left, so PV divided by RT. And we have all of those values that we need. So pressure, 101,000 pascals times my volume in meters cubed on the top. And then we're going to divide all of that by 8.31 for the gas constant times 273, nope, gosh, my apologies, 723. I was reading how I'd converted from degrees to Kelvin rather than the correct temperature, my apologies. So times 723. Now we can do this all in one go on the calculator. If we were to press our fraction button, and then we can have a bracket for the calculation on the top, and then a bracket for the calculation on the bottom. And that gives me my number of moles, so 3.78 times 10 to the minus 3. Now that is the number of moles of all 5 lots of moles of gas that we make in this reaction. So that is the number of moles for the NO2 and the O2. Now, if we want to be working back to find out some information about this M nitrate on the left-hand side, we can now use the mole ratios from the balanced chemical equation. So that is the moles for 5 lots of gas, and we have 2 lots of the initial metal nitrate solid. So I can take my moles of gas, divide it by 5, and then times it by 2, and that will get me then the number of moles of the metal nitrate. And that gives me 1.51 times 10 to the minus 3 moles of the metal nitrate. Now, hopefully it's feeling a little bit easier. Now we've got moles, we've got mass, and our first goal is to calculate the MR of that whole compound. So MR is going to be equal to mass over moles. and the mass we've been given is in grams, which is good. Occasionally they might give it in kilograms or milligrams, and neither of those are what we want. In this case, they've been very nice. 0.320 grams, and then we've just worked out the moles, 1.51 times 10 to the minus 3, and that will give us the MR of that whole compound, which is 211.5. So that's one of our answers done. Now, it hasn't specified in terms of how many significant figures or decimal places to give your answer to. In terms of any AR or MR values, it should be 1 decimal place, because all of the AR values on the periodic table will be given to 1 decimal place. And so when we add those up to get an MR, we should always be giving that to 1 decimal place. So the answer on my calculator gave me 211.507. So I didn't need to round the 5, but I chose to stop it there. So that's going to be the MR of the whole compound. And then if we want to work out the M part, we're going to need to figure out what contribution the NO3 twice makes to the MR, and essentially figure out what's left. And then that will be the AR of our group 2 metal. So 211.5. Take away nitrogen is 14. And we're going to have 2 of them, and you can do this in 2 ways. You can either do the N twice and the O 6 times, or you could add up the NO3 and then times that all by 2, whichever you prefer. I'm going to write it out as nitrogen plus nitrogen and then 6 oxygens, which would be 16 times 6. Bit inconsistent there, my apologies. I could have done 2 lots of 14.0. I just didn't really want to write out 16.0 6 times. So if I work out what that is, so answer, take away 14 plus 14 plus 16 times 6, I get an answer of 87.5, and that is therefore the AR of M. And in terms of how you'd then work out the identity of that, we'd get our periodic table and you'd be looking for the top number of a group 2 metal, because they've narrowed it down for us, that is 87.5 or very close to 87.5. And 87.6, I believe, is the value given on the periodic table for strontium. So metal M is therefore strontium. Now, because it says identity, it hasn't asked us for a name or a symbol specifically, so you could give either, so strontium or SR. If it obviously asks for name, give name. If it asks for symbol, give symbol. It just says identify M. So the metal was strontium. Hopefully all of that makes sense, but if anybody has any questions at all, obviously, as always, please feel free to comment on the video or drop me an email to missgtutoringandresources@outlook.com. Thanks so much for watching, guys. I hope you found it useful.